2024 has been a successful year at the Deer Creek Intake Project site near Provo, Utah. The successful partnership continues between the Provo River Water Users Association, AE2S Advanced Engineering, and Granite Construction. Another major player this year was microtunneling subcontractor James W. Fowler. With the entry and exit portals completed in 2023, we were ready for microtunneling and bypass pipe installation to begin. After a brief winter shutdown, the job site quickly came back to life in the spring of 2024. Fowler invited AE2S and Granite to California to look at a similar Heron Connect tunneling machine. After that, Fowler mobilized and arrived on site in Utah in March to begin mobilizing their equipment. This included a launch seal to keep the entry portal watertight, a jacking frame to push the MTBM and pipes through the mountain, and a separation plant to remove rock pieces and fines from the tunnel spoils. The microtunnel boring machine, or MTBM as we call it, arrived on site in early April 2024 and was ready to launch into the mountains soon after. The machine was named the Wasatch Worm, after the Wasatch mountain range that surrounds Deer Creek and provides water to millions of Utahns. The bypass pipe was delivered in 20-foot sections from St. Charles, Missouri, where they were fabricated by Trinity Products. The sections are made from 7/8-inch thick carbon rolled steel with an abrasive-resistant outer coating. They are joined together by Trinity's proprietary tri-lock joints, which provides a watertight seal using a system of interlocking teeth and rubber gaskets. The interior of each joint was also seal welded after installation for added protection. Each pipe was fabricated with a set of built-in ports that Fowler used to pump a bentonite lubricant around the outside of the pipe during the drive. The ports can then be reused for contact grout injection after the drive is finished. The first pipe in the string had a thicker section where the 68-inch steel bulkhead was installed to use as a plug when the machine would be eventually removed. Once launched, the contractor continuously pushed the machine through the rock, adding pipe to the end of the string 20 feet at a time. It was a repetitive process, but each day the worm inched closer and closer to its ultimate target. As the Wasatch Worm was making its way through the mountains, several of the original designers would stop by, and representatives from the Bureau of Reclamation, the Provo River Water Users Association, Advanced Engineering and Environmental Services AE2S, Black & Veatch, and the tunnel operators from Heron Connect, including Olivier from France and Russell from Washington. On July 13th, the MTBM finally reached the threshold for starting the wet recovery process, just 10 feet shy of the concrete head wall installed 75 feet underwater by divers in 2023. As a reminder, the head wall was built with a circular, unreinforced soft eye to serve as the target for the MTBM to hit when it exits the tunnel alignment. A wet recovery is when an MTBM finishes its tunnel drive underwater and must be brought to the surface to be recovered and is eventually reused on other future projects. This requires teams to work together from both sides of the finished tunnel. The recovery process began with redeployment of the crane barge, where we loaded with a 330-ton crane. And then we reinstalled the turbidity curtains to prevent sediment from entering the existing intake during punch-through. Not far behind was the dive barge, full of the crews of the divers and the equipment ready to receive the MTBM. As the MTBM slowly approached the head wall, we began to see pieces of grout in the tunneling spoils on the dry side of the dam. This is the same grout that was installed last year to secure the exit portal to the side of the mountain, and indicated that the MTBM was now within a few feet of the exit. At this point, several ROVs were in the water monitoring the head wall. The divers and many of the other team members watched the live feed from the surface. At 6:40 p.m., we were in our offices and up on the deck, and we saw the first signs of the punch-through as the small crack appeared in the bottom left corner of the soft eye, and bentonite slurry from the machine's cutter heads began leaking through. The team knew, and they held their breath in anticipation as the crack grew slowly and the machine carefully pushed its way through the opening. When the dust had cleared and the concrete from the soft eye was removed, ROV inspections revealed that the machine had hit its mark almost perfectly, within 2 inches of dead center. After pushing the machine to its final position, Fowler entered the back of the machine to seal everything off and, in their words, turn it into a submarine. The bulkhead was also sealed to isolate the microtunnel pipe from the reservoir. Once sealed, this door cannot be opened again until the bulkhead is removed from the reservoir in 2025. Now it was up to the divers to prepare the machine to be lifted to the surface. After attaching the crane rigging, they opened a port on the back of the machine to equalize the pressure. Hydraulic hoses were then lowered from a power unit on the surface and connected to that additional port. This allowed Fowler to actuate the separation cylinders at the back of the machine, slowly pushing it off the lead microtunnel pipe and allowing it to rest freely on the reception cradle. With all the precautions in place, the 330-ton crane slowly lifted the MTBM to the surface and placed it on the barge deck. As expected, the machine looked quite different on the exit side of the tunnel, with most of its red paint worn off and its cutter head wheels worn down significantly. This was a testament to the rough conditions encountered during tunneling. The divers then placed a custom fabricated pipe cap over the protruding microtunnel pipe to serve as a redundant plug for tunnel safety. With the cap secured in place, the team was ready to move the MTBM back to shore, where it was disassembled and loaded onto trucks to be taken off-site. Fowler then began grouting the pipe annulus. The grout was pumped through the same ports used for lubrication in each pipe to fill any remaining voids in the overcut. Each grout port then had to be plugged and seal welded to ensure water tightness along the entire pipe length. When the pipe was watertight, all that was left to do was to line the interior with an epoxy coating supplied by Tnemec. Gateway was the local painting specialist brought in to do the work. Paint crews worked around the clock until all 800 feet had been blasted, coated, and inspected by all coating experts. The final step was to seal off the microtunnel with a custom fabricated cap that was welded to the downstream end of the new pipe. This cap will remain in place as a secondary failsafe until the rest of the bypass piping is installed in 2025 and ready to be tied in. The divers had a second mission to accomplish while they were on site this year, which was preparing the original intake structure for some big upcoming project milestones. In 2025, when the bypass is fully online, the existing intake will be plugged with a 16-foot diameter bulkhead so that the entire system can be drained. To make room for the bulkhead installation, divers had to saw cut and remove one of the original concrete beams from the 1940 intake. The temporary steel beam was then manufactured and installed to support the structure until the bulkhead comes out in 2026. The divers were also able to remove all 36 trash rack screens from the intake and bring them to the surface where they were inspected. They will also be sandblasted and coated with a special coating designed to prevent aquatic invasive species. A temporary trash rack was custom built and installed to ensure the intake remains protected from debris. As the microtunnel interior coating was wrapping up, granite began to excavate around the existing concrete tunnel. This tunnel was built in the early 1940s. The new bypass pipe will eventually split into 2 separate pipes and tie directly into the 2 existing penstocks. To make this connection, about 24 feet of concrete tunnel needs to be demolished. Once the final grade was reached, a specialty wire saw cutting contractor was brought in to cut and remove the concrete in sections, each weighing between 6,000 and 10,000 pounds. A few specialty tools were brought in to perform the final cutting and chipping of the existing tunnel. This helped create a nice smooth surface from where the existing 1940 tunnel floor could join with the mat foundation of the new 2025 vault. Formwork and rebar for the foundation were soon delivered, assembled in place, and inspected. With all the winter precautions in place, Granite poured the 2-foot thick concrete vault foundation slab on December 19th, just in time for it to cure over the holidays. The Deer Creek Intake project also includes some high-performance double offset butterfly valves that were manufactured in Mannheim, Germany by VAG. In August, engineers from Provo River Water Users Association, Advanced Engineering and Environmental Services, and Granite were in Mannheim, Germany for additional factory acceptance testing, and all was successful. The valves were boxed and shipped from Germany, and in December they arrived on site in Utah. We are really proud of all the work we've accomplished in 2023 and 2024. We face a lot of unique challenges in the field, but with all the talent, experience, and partnering relationships we have on our team, we never lost focus of delivering quality. We are really excited about the next steps of this project and partnership. We want to thank all those who have made the progress possible and continue to make this project a huge success.